Okay, so in this example on slide 52 of our chapter 18 PowerPoint, we're going to be calculating 2 points on a titration curve of a strong acid with a strong base. So the information we're given, a 50 milliliter sample of 0.2 molar sodium hydroxide is titrated with 0.2 molar nitric acid and wants us to calculate the pH after adding 30 milliliters of nitric acid and at the equivalence point. So we're going to start with part A after the addition of 30 mils of nitric acid. So our strategy for this, hopefully you've been kind of looking and reading along with the PowerPoint, is to basically figure out the change in pH after addition of this nitric acid. So that means we're going to use a before and after chart. And if you remember, for a before and after chart, you have to have everything in moles, not molarity. So our first step for this problem is to convert both my base and my acid into moles, because right now we're currently in units of concentration. So part 1, or part A, if you will, we're looking for how many moles of sodium hydroxide we have. And in our problem it says we have a 50 milliliter sample of 0.2 molar sodium hydroxide. So remember, molarity can be broken down into moles over liters, and if we multiply our molarity by the volume, that's going to give us just moles. So in the problem, it says we have 0.2 molar sodium hydroxide. So I'm going to break that down into moles over liters. And it says we have 50 milliliters of it. So if I multiply this molarity by 0.050, which is equivalent of 50 milliliters, it's going to cancel the liter unit out, and I'm going to be left in units of moles. 0.0100 moles. Next part, got moles of base. Now I need to figure out how many moles of acid I have. And in this part, it says for part A that we've added 30 milliliters of nitric acid, and our molarity happens to also be 0.2 molar. So the same type of calculation, 0.200 moles per liter, and we're multiplying this now by 0.030 liters, and that comes from the fact that we've added 30 milliliters. So if you multiply, gets rid of our liter unit, and I'm left with 0.006 moles of nitric acid, and let me label that one up there. Alright, so now that I'm in moles, I can write my before and after chart. And before I do that, I need to write a reaction for this equilibrium. And basically, since we're strong acid and strong base, it's going to be OH reacting with hydronium. We're going to cancel out all the spectator ions. We're not even going to write those, and it's going to produce water. So the equation we're looking at is OH minus plus H3O plus gives us 2H2O. And I apologize if you can hear crunching in the background. My dog is currently chewing on a bone. Alright, so we have our reaction, and before and after. We're going to put in our mole amounts that we just calculated. So for our hydroxide, it's going to be 0.01 moles from our above calculation. And for nitric acid, 0.006. Water we're going to ignore because it's a liquid. And so now Since this is going in the forward direction, we're going to subtract, and to figure out what we're subtracting, we look at the two amounts that we have in our before portion. We figure out which one is stoichiometrically smaller. Hint, hint, that would be our acid. And we're going to subtract that value from both. So both are going to be minus 0.006 minus 0.006. For acid, that leaves me with 0. For base, that leaves me with 0.004 moles. So now, in order to eventually calculate pH, I need to get back into units of molarity. But we currently have moles, and we need to figure out what our new volume is. Because not only do we have our 50 milliliters of sodium hydroxide, we also have added 30 milliliters of nitric acid to it. So to calculate molarity, it's moles over liters, and it's going to be our moles over our new total, which is 0.05 liters from our original base solution and 0.03 liters from our additional acid. So we get that our new molarity of sodium hydroxide is 0.0500 molar. And that happens to also correspond to our hydroxide concentration. So if we know hydroxide concentration, we can figure out POH and use that to calculate pH. So we're going to use the equation pH plus POH is equal to 14, as well as negative log of my OH concentration is equal to POH. So if we do that, negative log of my 0.0500 molar, I'm going to get that my POH is 1.3. And then, if I plug that into my pH plus POH problem and take 14 minus 1.3 to give me pH, if I subtract those, pH is going to be equal to 12.70. So that's my answer for part A. Part B states to figure out the pH at the equivalence point. And this, I apologize for the marking and the dog whining, if you can hear that in the background. So pH at equivalence point, this is a super hard calculation, and it's based on the fact that when we mix nitric acid with sodium hydroxide, we produce, sodium hydroxide, not sodium chloride. We produce water and sodium nitrate. Now, sodium nitrate, it's a salt, and it comes from a strong acid and a strong base, which means it's got a neutral pH. So pretty much any time you have a titration that has a strong acid and a strong base, the equivalence point pH is going to be equal to 0, not 0, 7 for neutral. So we don't even need to do a calculation for this. pH is going to be 7 because it's a strong acid, strong base titration. All right, thanks for watching.